Hello students, so I welcome you in the lecture of linear integrated circuit. So in this lecture we will discuss about the syllabus of linear integrated circuit. So syllabus, this is the entirely on the second year with effect to 2020 and 21 syllabus. This is the latest syllabus, so we will see under the C scheme. So as far as your syllabus, what are the modules, what are the important bits are there. So as far as the linear integrated circuit, I am dealing with your linear integrated circuit theory as well as practical. So you will have three lectures. Okay, three lectures are there and you will also have a practical session of 2 hours in a week. In a week you will have a 2 hours practical session over there. I'm also dealing with your mini projects also. I am also dealing with your mini projects. So as far as theory and mark is concerned, there is two test. Test 1 20 marks, test 2 20 marks. Average you are getting is of 20 marks. Then end semester is of 80 marks. So 20 plus 80 you will 100 marks with that. And the exam is of 3 hours. Total 100 marks as well. And the practicals are there, external practicals. So term work is of 25 marks and the practical work is of 25 marks. So how much? 100. This is 100 marks and this is 50 marks. So 150 marks are there. So a very important subject as far as your marks and knowledge is concerned as a electronics and telecommunication engineer. So we'll discuss directly to the syllabus. Microcontrollers. Okay. So the linear integrated circuit. So linear integrated circuit, I have said that there is 3 hour lecture, 3 hours per week lectures are there total, and you have to give 20 marks theory, UT 20 marks unit test 2, and average you have to maintain out of 20. So 8 semester end semester exam total 100 marks and 50 mark for term of 25 marks and 25 mark for practical work. So there are, I think, 6 models are there. Yeah, 6 models are there. So out of that, there is first model, that is nothing but the introduction to the operational amplifier. So in this one, in the 7 hours, we have to see the block diagram, ideal and practical characteristics of op amp, then configuration like open loop configuration, closed loop configuration, inverting and non-inverting configuration of op amp, and buffer. So this is of point 1 and point 2. So out of that, ideal and practical characteristics are very important things. In exam, definitely you will ask a question, or in the theory, in the Viva, definitely one examiner will ask question on this one. Ideal and practical characteristics of operational amplifier. Normally we are using the 741 IC operational amplifier. We are using this IC in this particular syllabus. So after that, summing amplifier, difference amplifier, instrumentation amplifier using op amp. Means how to sum. Suppose you are having 4 volt, then 2 volt and 3 volt. Suppose if you want to add these voltages, so 4 plus 2 6 plus 3 6 plus 3 9. So 9 volt is the addition. So if you want to add, then if you want to take the difference and instrumentation amplifier. So how to design this one using operational amplifier, we have to see. This ends with your module number 1. So I will erase the part first. Okay. In the second one, you have to see the linear application of operational amplifier. So operational amplifier, that is we are using the short term as op amp. So op amp, there is a linear application like voltage to current converter and current to voltage converter, then integrator and differentiator, ideal and practical also. Then filters, first and second order low pass filter, high pass filter, band pass, band reject, and notch filters are there. Then in case of positive feedback, Barkhausen criteria, sine wave oscillator, RC phase shift oscillator, and Venn bridge. These are nothing but the linear applications. Okay, the linear applications are there. Likewise, you will have to go with the non-linear application in the third module, that is nothing but the non-linear application of operational amplifier. So here you have to see the comparators. You have to see the comparator like inverting comparator, non-inverting comparator, then zero crossing detector and window detector. So how window detector will operate and all that we will see in detail in our lectures. So In the second bit we have to see the Smith triggers. In the Smith trigger you have to see inverting Smith trigger and non-inverting Smith trigger also. Okay, then uh, waveform generator. So in the waveform generator we have to generate the square wave, then triangular wave, then in second bit we have to see the precision rectifier. So precision rectifier, in precision rectifier half wave and full wave precision rectifier. Then peak detector we have to see. This is all about the operational amplifier. Okay, operational amplifier. The second IC introduced is nothing but that IC 555. This is IC is known as timer IC or timer IC in application. So in this one we have to see its functional block diagram and working. Then design of astable and monostable multiplier using 555. Then application of astable monostable as pulse width modulator and pulse position modulator over there. Then in the voltage regulator we have to see the block diagram of voltage regulator. Okay, block diagram, that is nothing but the 3 terminal fixed voltage regulator, 78 axis series and 79 axis. This is the positive voltage regulator and this is the negative voltage regulator series. Okay, suppose if you want to regulate the 5 volt, okay, 5 volt over there, then you can regulate the 9 volt. Then you have to regulate 12 volt, you have to regulate 18 volt, and you have to regulate the 24 volt plus or minus. If you want to regulate plus, then you have to use the 7805. Okay, for 5 volt. So 78xx, these numbers indicate the xx indicate the last 2 digit how much voltage you have to regulate over there. Positive is 78 and negative is 79 over there. Then you have to go for the functional block diagram and working design of general purpose IC 723. Then high voltage low current and high voltage high current configuration only you have to see. There are 4 configuration as well as, that is nothing but the low voltage low current and low voltage high current over there. So for your syllabus there are again 2 configurations, high voltage low current and high voltage high current over there. Then introduction and block diagram of switching regulator, introduction to 317, that is nothing but the variable voltage regulator. Okay, so this is nothing but the module number 5. And in the last module what we have to see, just I will discuss. Okay, in the last module we have to see the special purpose integrated circuit. Special purpose integrated circuit, that is nothing but the block diagram of and working of VCO voltage control IC 566 and application of frequency modulation, application as frequency. Then functional block diagram and working of PLL IC 565 and its application as FSK demodulator, FSK demodulator. So this is the syllabus of linear integrated circuit. This is the syllabus of linear integrated circuit. So which textbook you have to refer? So Ramakant Gaikwad is the best book of linear integrated circuit. You can purchase this book because it will useful for your further education, further knowledge is concerned. And second is nothing but the D. Roy Chaudhary and S. P. Jain linear integrated circuit new age publication. These both books are there in our library, so you can use these both books. Also some reference books are there: Bodker, Sergio Franco, David Bell, Coughlin and Driscoll, and Millman. You can use these books, Millman and Hilkias. So these 5 books are there that are available in our laboratory also. Suppose if you want to go for the what you can say Swayam course, an NPTEL course, so you can click on this website and you will get the preview of entire NPTEL and Swayam course over there. So you can go there. So this is all about, I think so. Yeah, this is all about our linear integrated circuit syllabus discussion and all. So I hope you like this session. So if you are not subscribed my channel, please subscribe the channel. In this module, in this YouTube channel, I will cover each and every concept of linear integrated circuit in detail to you. So thank you very much for attending this lecture. Thank you.